Hello everyone, this is a CBSE XII Physics 3-mark question. The question reads, the following graph shows the variation of stopping potential V0 with the frequency nu of the incident radiation for two photosensitive metals X and Y. There is a graph between stopping potential and frequency for two metals X and Y. And the questions are, which of the metals has larger threshold wavelength? Give reason for it. Second, explain giving reason which metal gives out electrons having larger kinetic energy for the same wavelength of the incident radiation. And thirdly, if the distance between the light source and the metal is halved, how will the kinetic energy of the electrons emitted from it change? Give reason for it. So this is a question from dual nature of radiation matter. And the key concepts which will be used in this question is, number one, we know that lambda is inversely proportional to nu. Secondly, the work function is given by h nu naught, where nu naught is the threshold frequency. And thirdly, kinetic energy is independent of the intensity of light, intensity of incident radiation. So now the first question, which of the metals has larger threshold wavelength? These are the two metals X and Y, and the graph is showing the variation between stopping potential and the frequency. Now, the threshold frequency of metal X is 0.5, whereas the threshold frequency of metal Y is 1 into 10 to the power 15. Now we can see from the values that the threshold frequency of metal X is less. So since wavelength is inversely proportional to the frequency, so metal X will have more threshold wavelength. Second part, give reason which metal gives out electrons with a larger kinetic energy for the same wavelength of incident radiation. Now we know that by Einstein's photoelectric equation, E is equal to work function plus kinetic energy maximum. So since the wavelength is same, so the energy of the incident photon will be same. So this is constant. So if work function is less, the kinetic energy will be maximum, or if work function is more, kinetic energy of the emitted electrons will be less. So here we can see in the first part of the question, we have seen that the X metal has less work function because its frequency is less. Phi is h nu naught. So since its X metal has less frequency, its work function is less. So when the work function of metal X is less, the electrons which will be emitted from metal X will have maximum value, or the electrons emitted by metal X will be having maximum energy. Third is, if the distance between the light source and metal X is half, how will the kinetic energy of the electrons emitted from it change? Give reason for it. So here the distance between the light source and the metal is reduced to half. So when the distance is reduced to half, the intensity will increase. Intensity will increase. But we know that kinetic energy is independent of intensity. So since the kinetic energy is independent of intensity, there will be no change in the kinetic energy. no change in kinetic energy of the emitted electrons. Hope the question is clear to you. Thank you. If you want to see my further videos, kindly subscribe my channel.